In this final Tool Manager lesson, we'll explore the process of creating a tool inside of Mastercam using an imported file that you might have downloaded from a tooling manufacturer's website. To start, I'm displaying on the screen the specs of a tool that I downloaded. Now, I downloaded this tool in a step format, and if I bring in that file, you'll notice that it comes across as an actual solid file. And if I zoom out and reposition the model, you can see that we have a cutting area down below, we have some tapered areas with a slimmer neck, and then a larger shank at the top. I'm pointing this out because in many cases, users may expect that since they downloaded the file, you can simply bring it into Mastercam and use it. However, that's not always the case. So to start, let's explore an example of using Mastercam with a specific custom tool. I'm going to bring in this file called tooling example. And as you can see when I zoom in, there's one particular toolpath I want to focus on, and it's the last toolpath number 15. If I simply backplot this toolpath, you'll notice that when we get up to the top here, it interferes with this boss up here. And that's just a simple matter of adding an avoidance region. So let's do that first. We'll go into the parameters and we'll add this top face as an avoidance region. And now when we regenerate this toolpath and explore the results, you'll see that the toolpath now avoids that boss. So that's the first step. And if we take a look here, it's going right up to that boss. So now I'm going to copy this toolpath. And the reason I'm going to copy it is so we can always compare it to the original. And in this new toolpath here, I want to create a new tool that I can use. So let's go into the parameters. And under the tool section, I'm going to right click and choose create tool. It'll be a ball end mill. And when I click next, I can actually use these buttons up here, specifically this one here, to import custom geometry from a file. So I'm going to pick the step file that I just downloaded. And as you can see, it comes in perfectly fine. Now let's just accept all the standard defaults. And maybe the logic here is, I downloaded the file, what else do I need to do? Everything should be set up. So I'm just going to hit next. Look here, maybe change this tool number. Let's just call it 30 so we can actually reference it later. And I'll hit finish. So now there's a tool called tool number 30. And we'll call this imported tool, no modifications. So I'm going to select this tool path and regenerate it. Now let's backplot this tool path and see what we get. As you can see, the tool is displayed properly, or more specifically, the tool is displayed the way we saw it when we downloaded it. And when we backplot it, let's go back to this area that was the question earlier. And as you can see, the tool stays away from this edge. So this could be a support issue. It could be a confusion that happens with the user as we don't know what's going on. Now, what's really going on is that the tool that you see and the tool that Mastercam uses to compute the toolpath motion might be very different. So to explore that, let's copy this toolpath again and explore the tool definition. So I'm going to right click, copy this again, and now we'll look at toolpath number 17. And I'll click on this tool. Now when we look at this toolpath definition, what we saw earlier, and I briefly looked at it, was this outlined shape here. And this outlined shape here is what the Mastercam tool is. So what that means, and you can see it right here, outlined Mastercam tool, this is the geometry that Mastercam uses to calculate the toolpath offset relative to the geometry. So it's actually not using this geometry right here. It's using this geometry. And you can swap those two displays. So for example, if you want to render the Mastercam tool, you can render this tool. And of course the outline now is the imported model. Let's switch back to the way it was for the sake of consistency. So to really get the benefit out of this tool, we need to go in and update our cutting specs based on the manufacturer's settings. So off screen, I have the values that I downloaded from that website, and specifically, I'm going to update them here. So the cutting diameter is actually 4.763 millimeters. And when I hit tab, you can see that things start updating. And now you'll see that my diameter, the cutting diameter, is accurate. And now you can see it's a little off here, which might not be a big deal. But right from the start, we're starting to improve the definition of this tool. The overall length is 76.2 millimeters. And let's actually zoom this out so we can see some of the changes happen. The cutting length is 4.775. Now you'll see down here that this is getting updated. The corner treatment, or the radius in this case, is 1.588. And these are all in millimeters. The shoulder length is 19.05. The shoulder diameter, in this case also known as the neck diameter for this tool, is 4.66. And the shank diameter is 6.35. Now, as you can see, we have a much more accurate representation of the tool. And just to compare, we could change this. Let's just say this was 125. As you can see, Mastercam will compensate to this value. However, what you see when you backplot will be this outside value. We'll go back and change these values. And again, that radius was 1.588. So now to reiterate, we have a Mastercam defined tool, which is the outline, and it very closely matches the rendered tool. And you can look at the rendered tool as really just being a representation of the tool for verification purposes, which is not necessarily what Mastercam uses to calculate the toolpath. I can hit next. I'm going to call this tool number 40, and we'll click finish. And in this case, I want to create a new assembly because I want to keep the old tool as well for comparison purposes. And let's go in and regenerate this toolpath and investigate it. And as you can see, this tool goes right up to it. And that's because we have a properly defined tool. What we're seeing here is the rendered tool, but since it very closely matches the Mastercam defined tool, it looks perfect. And if you zoom out, you can tell that early on when we brought in this tool and did not change any settings, it had a straight shank that went right down to the cutting diameter. And that's what Mastercam used to calculate the toolpath, which is why the original toolpath, this one right here, didn't come up against the wall perfectly. And that's because it was actually compensating to the diameter, as we can see right here. If you zoom out, you'll notice that if you extend this line down, It's actually compensating to the mathematical tool, which comes way out here. So in summary, if you go into creating a new tool, you have many parameters to choose from. I recommend not using the custom tool setting, as this is not necessarily parametric, and we use this more for old legacy files. So for example, if you have a Mastercam file from the X series of Mastercam, like Mastercam X7, X8, and so forth, this custom tool setting would be used to handle those custom tools. What I recommend is to choose the closest parametric tool available here. So as an example, you may download a flat end mill, but that flat end mill has a radius on the corner. Well, you may not necessarily be choosing this tool then when you're defining your tool. You may choose a bullnose, even though the tooling manufacturer categorizes it as an end mill. Once you choose the right tool, then you fill in the properties as accurately as possible to get your rendered tool to match your Mastercam tool. All of the Mastercam toolpath calculations work off the parametric definition, which is defined right here. So even if you go backwards here and choose something like a lollipop mill, everything is calculated off of these values. So the closer these values are to your actual tool, the more accurate your toolpath will be. And if you're wondering what the imported tool definition is used for, so in other words, the rendered tool that is used when you're in Backplot, that tool is used for stock model calculation, simulation, verification, and some other anti-collision efforts. Anything that's after the toolpath calculation that you would typically see in the Mastercam simulator. So as you can see, creating custom tools is extremely powerful. However, it's very important to make sure you have the properly defined tool so your toolpath is calculated accurately based on those parameters.